Yes, I want to take this opportunity to welcome the class to our topic today, where we are handling engineering mathematics for level 5 and level 6. So today we are going to look at hyperbolic functions. Initially, I had introduced trigonometric functions, where we looked at trigonometry, the unit circle, and we looked at the trigonometric identities. Later we looked at trigonometric equations, and today we are going to look at hyperbolic functions, which are related closely to trigonometric functions. Thank you. So we begin with, I begin by reminding you that you can visit page 3 of the SMP tables that I had shown you previously. This is the SMP table. That's how it looks at the back, and that's how it looks at the front. On page 3, we have a reminder that sine x, actually it is called sin x, is equals to a half e x minus e negative x. Cos x, that is hyperbolic cosine, is given by a half ex plus e negative x. So those are the reminders. Then we have tan, hyperbolic tangent, that is than x, is given by sin x divided by cosine x, as you can be able to see. Very clear to us. It is being given in terms of exponential numbers. That is exponential x plus exponential positive x minus exponential negative x, and this is okay. Okay, so with that, we will be started, and as you see, that cosine is always positive, but it's always you add in the middle here, and as you can see, cosine is given there. There is a negative there, and that is okay. Then x, this is tangent, hyperbolic tangent. Actually, the letter in between here is refers to a hyperbolic the function. So this is hyperbolic tangent, this is hyperbolic cosine, this is hyperbolic sine. All right, okay, so we will be already started. We already started, and you can take your time to look at the 3, and as you do, we want to do some manipulations here and there so that we can be able to see how the values vary with respect to x. Yes. Thus you can be able to see that that is what we have, and I would say at this point that let's take, for example, we know the trigonometric identity that sine x plus 2 sine x, sine 2x is given by 2 sine x cosine x. This is an identity in double angle. That's an identity double angle. That's what we have. So let's see if at all it applies in hyperbolic for hyperbolic functions. In this case, we are going to use the the left hand side, the right hand side, to see if it can be able to prove the left hand side. I'm going to take the right hand side to see if it will be able to give us this is the right hand side. All right, we're going to see if it's going to prove the left hand side in terms of hyperbolic functions. So we will write them in hyperbolic nomenclature. That is going to be sine 2x is given by twice sine x cosine x. That's how we are going to write it. And let's look at the right hand side. The right hand side to see if it will be able to prove for us the left hand side. Well, welcome and see what happens. So the first thing is that we are going to replace sine x and cosine x in their respective places according to our definition there. So we are going to have 2 multiplied by a half. Sine x is given by that, e x minus e negative x, like that. And there is a multiplier. Then there is also cosine x, which will be given by a half, e x e negative x, positive here, like that. Then we close our main bracket. Now we close our main bracket. I hope that the class you're able to follow and see what is happening here. So a quarter multiplies with a quarter to give, a half multiplies with a half to give us a quarter. So as you can see, there is a multiplier here. So this gives us a quarter. So this is going to be 2 multiplied by a quarter. Then this is going to be, we are going to multiply, open the brackets here, so that we have, first of all, let's write it like that. Then we write ex minus plus e negative x, like that. Like that. That's how we write it. From there, we now see that this one can cross this one to give us a half. So we have a half here already. And then we multiply this by this. Multiply exponential x, multiply by exponential x. It gives you exponential x plus x. That's how it happens, because when you multiply the bases, what do you do to the powers? Class again, remember, when you multiply the bases, I said, when you multiply the bases, you do what? You add the powers. That's what we say, and that's what you're doing here. So you're multiplying this and this, e and e bases, so you're going to add the powers. Well, having said that, e multiplies with the second, this multiplies with the whole of this. So e multiplies with the whole of this minus e multiplying with again the whole of this. So e has multiplied with the first item, so we add to e multiplying with the second item. That's going to be e x minus x. All right? Good. Minus, so this is minus e negative x plus x, because it's multiplying here, right? Then lastly, we're going to have negative ex multiplying by e negative x. So that's going to be minus x, like that. So that is what you're going to have. So if you see clearly, x minus x gives us 0. And any number power 0 is, what is it, class? 1. It is 1. Any number power 0 is 1. And I told you last time when I was in class that when you raise a number to 0, then that number becomes 1. So class, we're going to have a half e 2x plus 1 minus 1 minus e minus 2 minus x gives us minus 2x. Close the bracket. So you see minus 1 crosses out to give you 0. And so we have this, we can come to this side. Come to this side and write our finding. Our finding is e 2x minus e negative 2x. That is what we receive. So as you can see, we have this. And actually, this one compares, if you can compare sine and cosine, this is for sine. But what has changed? We have a half here. We have this has changed. That is what has changed. So, but the change is good. Now that gives us the angle. That gives us the angle. So you see now the right hand side gives us sine 2x, which is equivalent to the left hand side. So that one has been proved. So that one has been proved. So that one has been proved. That one has been proved. So with that, we go to the second identity. So with this, we now know the first trigonometric hyperbolic identity is that one. Yeah. So this one is proved as our trigonometric hyperbolic identity. That one has been proved to be our hyperbolic identity. Is it okay, class? Is it okay, class? Good, good, very good. So we begin on our second. We want to also see how it behaves. We want to also see how it behaves. We also want to see how it behaves. Remember, I shared with you what we refer in mathematics, what we refer to as the what did I say again? The fundamental trigonometric identity. We want to see how it behaves. The fundamental trigonometric identity. Class, can anyone tell us the fundamental trigonometric identity? Very good. Yes, that one. So the fundamental trigonometric identity we shared last time was cos squared x plus sine squared x equal to 1. That's what we say. That's what we say. Very good. Very well done, class. Thank you for remembering that. Now, writing this one in hyperbolic, it will be written as what? It will be written as cosine squared x plus sine squared x is equals to. Now we do not know what it will be equal to, but we just write 1, but to be proved whether it is correct or it is not correct. So again, we have to recall that cos x is given by a half ex plus e negative x. We have to recall that. We also have to recall that sine x is given by a half ex minus e negative a half. Once we have those two, then we are good to go in our manipulation today. So let's begin with cosine. So cosine squared is going to be cos squared x plus sine squared x is equals to what? So again, we want to see if at all it's going to give us whatever it's going to be able to be gotten from that. So we're going to have a half ex plus e negative x squared. So we square the whole of this. Then we add to the square of a half ex minus e minus x. We square. We want to see what we are going to get. So from here it is very clear to us that we will square this one to give us a quarter. So we want to square this. So when you square, you need to square the first number to give us 2x. Then we add it to twice the sum of the two numbers. Twice the sum of the two numbers plus e minus x, like that. That is twice the sum of the two numbers. Then we add to the square of the other number. That is going to be e negative 2x. So we are finished with this part. So we go to this other part. Plus, we go to this other part, which is going to give us, let me write up there. Let me write up here, because I can see you might have challenges seeing that. So that's going to be a half, a quarter again. You square this part, you're going to get a quarter, and then you square this bit inside here. So when you're squaring a number like this one, you square the first bit. That's going to be e 2x. Then you add to the sum of the two numbers. The sum of the two numbers. That is going to be plus 2 e x minus e negative x. Actually, it's not the sum, I'm sorry. It is the product. We are multiplying. It is the product of the two numbers. Now, in this case, we are subtracting. Why are we subtracting? Because one of the numbers is what? Subtracted. But here we add, because one of the numbers, the second number is added. So we subtract twice of that, plus the other part, this other part squared is going to be e negative x, like that. So add what is in the brackets. Add up what is in the brackets. Again, we are going to have this one and this one as 0. So we're going to have equal to a quarter. The first part there is going to give us e 2x, and then this is going to give us 2 plus 2 e0 plus this part here is e negative 2x. Then we add this one, added to a quarter. We can have a quarter. This divided by 4. This is a quarter. Sorry. That is a quarter plus, again, a quarter. E, this is 2x minus 2 over 4, because it's 2 divided by this 4. So that is 2 over 4, e 0. Then this is 0 because it is x minus x. When you're multiplying the bases, you add the powers. And then plus a quarter e negative 2x. So when we add the like terms, as you can see, this and this adds up to give us, that one there adds up to give us a half e 2x. And this one here adds to this one, actually cancels out. As you can see, they'll cancel out. Plus 2 over 4 minus 2 over 4 will cancel out to be 0. So we'll forget about them. Then we come to this one, a quarter, and a quarter will give us a half e negative 2x. e negative 2x. If you group it together, it's going to be a half e 2x plus e negative 2x. So class, this one looks like one of the hyperbolic functions, the one we just got in the previous work, not the one we got in the previous work, but as you can look at it cleanly, it looks like cosine. This one is cos 2x. So this one is actually equivalent to cos 2x. That is what we have. So as we see, this one is not actually equal to 1. When you look at the equivalent, its equivalent in hyperbolic, then it's not actually equal to 1. It's actually equal to what? Cos. It's actually equal to cos 2x. So that brings us to our second identity in in hyperbolic functions. So you can be able to follow keenly to see what is happening here. That is an equal sign, that is an equal sign. So that's what we have. You add the two, that is cos squared, sine squared, and that's what you have. If opening the bracket, we open the bracket this way, then we came and we added that. We came and we added that bit, and we came and added that bit, and then after we did that, we open this bracket. We open the inner bracket. Open the inner bracket here. We open the inner bracket there. When you open the brackets, you're multiplying the bases, so you do the necessary to the powers. That is, you add the powers, and therefore this brings us to our second hyperbolic, identity. Gives us our second hyperbolic identity. So as you can see, our first hyperbolic identity has been 2 sine x cos x is equals to twice sine 2x, twice sine 2x, and cos x plus sine squared x, cos squared x plus sine squared x, cos squared x. This gives us our first identity. This gives us our second identity as we move forward, Now let's look at another one. Let's look at another identity. Let's look at another identity and see how that one behaves. We want to see how that one does what? How that one behaves. How that one behaves in hyperbolic functions. We want to see how that one behaves in hyperbolic functions. All right? I hope we are together, class, as we proceed, so that I don't leave you behind, even as we move ahead. You know what? We must always go on, you know. The wheel is always going on. You know what? That is what happens. And so the wheel of time is always going ahead. So we cannot remain behind when others are going ahead, right? All right, welcome as we continue on our third hyperbolic identity. We know from trigonometric identity that twice cos and 2 cos, we say cos 2 theta, so not twice cos but cos 2 theta is given by 1 minus cos squared theta. So let's look up in our SMP for the reminder. And our SMP is right there. Our SMP reminds us all these things. I said there is no need for struggling. You always need just to open the SMP, and you know what? you have all of those particular identities right with you. You have all those particular identities right with you. So cos 2 theta is given by cos 2 theta is given by cos squared theta minus sine squared theta. Sorry, not cos squared, but sine squared theta. So we have cos squared theta minus sine squared theta. That's what we have. So this is what we have. But does it hold? Does it actually hold in hyperbolic? So that's what we need to prove. So we want to prove whether the right hand side conforms with the left hand side. We want to see whether the left hand side conforms with the right hand side. In this case, we're looking at the hyperbolic functions. The hyperbolic functions. So writing it in hyperbolic, it will look like cos squared theta minus sine squared x. Call it x. No problem, x and theta. So we want to see what that one will give us. So again, we will put our half ex plus e negative x minus a half ex minus e negative x. So we do not know what that's going to give us. So opening the brackets class, we will have, opening the brackets in this case, plus we're going to have a quarter e x plus twice e x, we said 0, plus e negative 2x minus a quarter e x minus 2 e 0, right? E 0 plus e minus 2x, like that. That's what you're going to have. So this is an equal sign. That is a half. So again, a half is squared, and also whatever is inside here is squared. So a half is squared, and whatever is inside there is squared. So opening the bracket, that is the lion, or we call it the elephant in the room. Class, that is what we call what? The elephant in the room. Yes, that is the elephant in the room. So how do we deal with the elephant in the room? It's very easy to deal with the elephant in the room. Simply come out of the room and look for a pistol, and you know what? Do the necessary, right? Okay. So we have come out of the room. We want to look for a pistol and see how the pistol works today. You see that, right? Okay. So open out. This gives us that. Opening out, this gives us 2 over 4 e 0. This gives us plus 1 over 4 e negative 2x. Opening this one out, remember this is a minus. So this gives us minus a quarter e x. So this was 2x. This was 2x. This is 2x. Supposed to be 2x, right? 2x. Then this and this gives us plus 2 over 4 e 0, right? 2 over 4 plus. Then minus times that gives us minus a quarter e negative 2x. So when we do the sum of that, we do the sum of that. When we do the sum of that, what is it going to give us, class? This one and this one, they are going to be cancelled out. You're going to cancel this one out. Going to give you 0. So this is going to be 0. And this one, they are going to give you 1 plus 1, because this is a half. This one here, this is a half. Half plus a half gives you 1 plus 0. You see now? So the left-hand side, the right-hand side has come to 1. So that gives us our third hyperbolic, what? Identity. Identity number 3 comes to us. So you see the right-hand side is equal to 1. So the right-hand side is equal to 1. So we are going to write it cos squared x plus sine squared minus sine squared x, cos squared x minus sine squared x is equals to 1. Is equals to 1, as you can be able to see. So that is equivalent to 1. That gives us our third hyperbolic identity. So you can see that we can craft we can be able to craft out the hyperbolic functions from the trigonometric functions. We can be able to craft out the hyperbolic functions, that is hyperbolic identities, from the trigonometric identities. As you can see, that is very, very, very clear to us. So that is very, very clear to us. So that is important. So it is good for us to know that and see how we can be able to work that one out. So as you can see, we have been able to learn the trigonometric functions, and now we have been able to see how to get the hyperbolic functions from the trigonometric functions. So quickly we turn our mind to something else, that is hyperbolic equations. So hyperbolic equations, as I said in the previous classes, is that we start with the simplest. The hyperbolic equation, the simplest we have, is sine x is equals to 1. Sine x is equals to 1. So what are the values of x if sine x is equals to 1? What are the values of x if sine x is equal to 1? Can anyone try? Can anyone try to give us the values of x? Class, can anyone try to give us the value of x? Very well done. What we will do is simply what they have said. We are going to replace sine x with what it means in equations. So what it means in full is a half e x minus e minus x, like that, equal to 1. That is what it means. Well said. So from here, you multiply a half you multiply by 2 on both sides. Multiply by 2 on both sides. That's going to be EX minus EX is equal to 2. You see that? E is equal to 2. All right. So from there, we divide through. We divide through by E negative X. We divide through by E negative X. We divide through, or we can say we multiply through by EX. Multiply through by EX. Multiply through by EX. Why would we do that? Rewriting this one, we'll have EX minus 1 all over EX is equal to 2. So at this point, we will say we will multiply through by EX. So multiply through by EX. You're going to have E 2x minus 1 equal to 2 EX equals to 2 EX. So collecting this one on this side, bringing this one on that side, what are we going to have, class? What are we going to have? We're going to have we're going to have E 2x minus 2EX minus 1 equal to 0. So at this point we let EX be M. Let EX be M. Or you can say Y. No problem. So that's going to be Y multiplied by Y minus 2Y minus 1 equals 0. So Y multiplied by Y is simply Y squared minus 2Y minus 1 equal to 0. So this one is what? This one is quadratic equation. This is quadratic equation. So class, can anybody help us to solve that quadratic equation? Can anybody help us to solve that quadratic equation? Well said. Yes, we're going to use the formula method. Going to use the formula method. And what is the formula method, class? Can we remember the formula method just in case we forgot the formula method? We are reminded on page 3 of the SMP table. On page 3, we are given that Y can be given by minus B plus or minus B squared minus 4AC square root over 2 multiplied by A. So you see the SMP is very handy for us in hyperbolic as well as other manipulations that we might be having. So in this case, our B is what? Our B is negative 2. So negative B is positive 2. So this is going to be positive 2. 2 squared minus 4. AC gives us minus 1. All over 2 multiplied by A, which is 1. So the answer is going to be 2 plus or minus 8, right? Plus or minus square root of 8 all over all over 2. So as you can see, we are going to have 2 plus or minus 2 root 2 all over 2. Again, this is how we write number 8 in third form. That's how we write number 8 in third form. So we are going to have 2 root 2 like that. So as you can see, we are going to have our first answer is going to be 2. If we take the positive, that's going to be 2 plus 2 root 2 all over 2. Or it's going to be 2 minus 2 root 2. Our chalk is done. So we pick another chalk plus, pick another chalk, and continue. Minus 2 root 2 divided by 2. So this one requires a calculator for us to be able to get to the answer of that one. So that's going to be 2 2 divided by 2 plus 2 root 2. So the answer there is 2.4142 or negative 0.4142. So those are the two possible answers. That we have. So that is why. What about EX? EX is equals to 2.4142. So what is X? Will be, so you find the natural logarithms on both sides. You find the natural logarithms of both sides. Alright? Yes, that's how you do it. You find the natural logarithm of both sides. And that's going to be natural logarithm of EX is equals to the natural logarithm of 2.4142. So here you're going to have X is equals to, so you look for the natural logarithm on your calculator. We have the natural logarithm, which is ln. So you press ln 2.4142. So the answer there is 0.88136. Or natural logarithm of the minus number. Math error. So it cannot be able to find the natural logarithm of a negative number. That's why it is giving us math error. You ever seen something like this on your calculator? Yes. So whenever you see math error on your calculator, it tells you that whatever you are looking for cannot be found mathematically, or it is too big to be displayed on the calculator. So we have the value of X as 0 point that, and sure enough the value of X is that, and sure enough you can be able to prove that by going to the hyperbolic functions, and you pick on shine and you pick on 0.8, you write 0.88136, put an equal sign, it gives you 0.999, which gives us 1. So proving this one, it simply means that we can be able to do it by putting there that value and it gives us 0.999. Proof: shine 0.88136 is equals to 0.99998, which is approximately 1. So that is how we solve. So solving of hyperbolic functions, this simply means find the value whose hyperbolic function will give us the answer on the right hand side. And that is how we are able to do that. That's how we are able to do that. All right? Okay. That is simple as that. So meet you in the next class for other examples. Thank you very much. Thank you for listening.